Hey, we are working on Chapter 2, Section 8, Analyze Graphs of Polynomial Functions. Our warm-up, we're going to multiply this, which means I'm going to FOIL. Remember, FOIL is first, outer, inner, and last. And then we collect the like terms in the middle, and we get 3x squared plus 7x plus 2. That is a squared. Find the intercepts, and if we remember, I have any graph. I've got two x-intercepts, okay, right there and right there. X-intercepts is where the y value equals 0 and the x equals a number, and then I have a y-intercept, which is where the x value equals 0, and we have a value of x. Or x equals 0, we have a value of y. So let's do our intercepts for this. These two right here are going to be our x-intercepts, which is when y equals 0, x plus 6, x minus 5. That means x equals negative 6, and x equals 5. Cool? Now the y-intercept is when x equals 0. So we get 0 plus 6 times 0 minus 5, which is negative 30 is the y-intercept. An object is projected vertically upward. Its distance d in feet above the ground after t seconds is given by that equation. Find its maximum distance above the ground. Okay, what we're doing here is I have t and d and a projectile up and down. Okay, the maximum, which is right here, is going to be halfway between our two intercepts. Okay, so halfway between there, and then if I go straight up, I find the maximum. So I'm actually going to use quadratic formula because I can't solve this by hand. I can't factor it. And quadratic formula is t equals negative 144 plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, let's simplify that. Straight down there. So there are my two t-intercepts. Got negative 0.647 and positive 9.647. So halfway between that, I'm going to add those two numbers together. 0.647 divided by 2. I get the halfway point is t equals 4.5. I did round a little bit. So if I plug this t back into the equation, I'm going to get the d at the highest point. So I'm going to use some calculator magic. Not really. I'm not going to use yellow though. So negative 16 4.5 squared plus 144 times 4.5 plus 100. Be right back. And I get my height as 424 feet. Okay, that was a lot of work for a warm-up. All right, what are we doing today? Let's see. In this chapter, you have learned that zeros, factoring, solutions, and x-intercepts are closely related concepts. Their relationships are summarized below. So we have zeros. Let's see. Zeros. K is a zero of the polynomial function of f. We don't have k's up there yet though, so let's not worry about it. But when we factor a polynomial, we get x minus k is a factor, And then we set this equal to 0 and solve for k like this. We would have x minus k equals 0, therefore x equals k is a 0. Solution. K is the solution of the polynomial equation because we set it equal to 0. So we have 0, factor, solution, and x-intercept. If k is a real number, k is an x-intercept because it crosses the x-axis. There's k and there's k. The graph passes through k comma 0 because y equals 0 at the 0 or the solution. Okay, graph the function. Remember, these are the zeros. And we also learned that when it's a squared value, it just touches the x-axis at the 0, right? Okay, let's erase that and start over. That was just my little reminder for you. Okay, my zeros are x equals -3 and x equals 2, twice. So 2, 1, 2, 3. There and there. Okay, so that is the first thing we do. Next, we need to plot some points between and beyond the x-intercept. So if we set up a table x, y, my x-intercepts are -3 and 2. So I'm going to plot a -4 and, I don't know, let's do a 0, which is always easy, and a 3. Okay, so we have the zeros and some more. So our y value is going to be 0 there, and our y value is going to be 0 there. If I plug in -4 to the equation, I get here, this would be -4 plus 3 is -1, and -4 minus 2 is -6 squared. If I crunch all my numbers for this one, what you can do with your calculator, I'm going to get a -6. If I plug 0 in for x, I get 3 times 4, which is 12, divided by 6 is 2. And if I plug 3 in, fancy calculator work, I get a 1. So if we plot these, I'm going to have -4, -6. 1, 2, 3, 4, 5, 6. Way down there. 0, 2. And then 3, 1. Remember we talked about this one. This is where we just get a touch on the x-axis. So if I were to try to graph this, okay, let's try. It would look something like that. Oops, I missed that point down here. Cool? That was the key for me to remember, that right there is going to be our touch. All right, more reminders. Now we're talking about turning points. Another important characteristic of graphs of a polynomial function is that they have turning points corresponding to local maxima and minimum values. The y-coordinate of a turning point is the local maximum if the function of the point is higher than all nearby points. Okay? It's a maximum if it's the highest point on the curve. The y-coordinate of a turning point is a local minimum if the function if the point is lower than all the nearby points. Notice we said that the y-coordinate of a turning point, these local maxima and minimums have x and y values in their coordinates, but we're just talking about the y-coordinate. Okay, so summarizing turning points of polynomial functions, the graph of every polynomial function of degree n has at most n minus 1 turning points. So if we are a third degree polynomial, degree equals 3, the degree n equals 3, we're going to have 2 turning points. If we are x to the 4th, we're going to have 3 turning points. Right? Okay. If a polynomial function has n distinct real zeros, then its graph has exactly n minus 1 turning points. Right. Graph the function, identify the x-intercepts and points where the local maximums and local minimums occur. We are actually going to do this using our graphing calculator. Okay, so you pull out your calculator and go ahead and type that function into it. Okay, we type that in and we graph it. We notice that the graph of f has one x-intercept and 2 turning points. So we have one x-intercept and 2 turning points. Here and there. So it's a local maximum and a local minimum. Now we've gone over in class that we can use a calculator to find the zeros. Well, we can also use a calculator to find the maximum and minimum. Okay, it's that same second calc function, right? So you still have that graph in front of you. Looking at the zero function on your calculator, we can find that the zero is approximately negative 1.2. And we can do the local maximum, which is just the y coordinate, at 0, 6, just so our local maxima is 6. And the local minima is the y value at 2, 2. Okay, next one. Go ahead and plug it into your calculator and graph the function. Notice I have 1, 2, 3, 4, 4 x-intercepts. And 3 turning points. There, and there. 2 minimums and a maximum. And we can use our graphing calculator to find all of those. So my x-intercepts, it's a lot of calculator work because these are not whole numbers. 0.29, approximately 1.82, approximately 5.03. I'm missing one, and negative 1.14. Okay, we have 3 turning points. So my first one is actually a minimum right there. And the minimum is at about 1.11, 5.11. Except that's a maximum. Haha, I caught my mistake. So we have our minimum at negative 0.57 and negative 6.51. 3.96 and 43.04. That minimum is going to be hard to see on that calculator though. Okay, you really have to work on your window. And then our local maximum is 1.11, 5.11. Cool? All right, moving on. Right, example 3. This problem right here, I've done in Algebra 2 for a few years, and we actually made boxes and calculated volume, but it's really neat. So you're making a rectangular box out of 16-inch by 20-inch piece of cardboard. The box will be formed by making the cuts shown in the diagram and folding up the sides. You want the box to have the greatest volume possible, so we're maximizing the volume. How long should you make the cuts? What is the maximum value, and what will the dimensions of the finished box be? So here's our box. It's a 16 by 20 piece of cardboard, and we're cutting out really the corners to fold up to make the box, right? So we need equations to represent the length times the width. Okay, the length and the width. The length and the width is going to be the base of the box. So I really take 20 minus x, or 20 minus 2x for the length, and 16 minus 2x for the width. For volume, we also need to know the height of the box. I just gave it away. The height of the box, which is your x value, right? So our volume is going to be length times width times height, which is 20 minus 2x. That's a 2. Goodness. Our width is 16 minus 2x, and our height is just plain old x. So this is in fact our volume. Okay, I need to do some multiplication. We did this. I guess I can do the multiplication here. Volume is going to be, let's multiply these together first. First times first, 120 times 16, 32, 320. Okay, first outer minus 40x inner minus 32x, and last plus 4x squared. Let's collect some like terms. 320 minus 72x plus 4x squared. I'm going to multiply that times my height, which is x. So the volume is, I'm going to put this in standard form, the right order, 4x cubed minus 72x squared plus 320x. That is my volume. Cool. All right, to find the maximum volume, we're going to graph it. And again, when you're in your graphing calculator, the window can be the hardest thing to look at because you need to make sure you can see the whole graph in your window. So to find the maximum volume, we're going to graph the volume function on a graphing calculator. And we actually only want to look at an x value from 0 to 8, because if you remember, our cardboard size is 20 inches by 16 inches. So that x value is our flap. Okay, if you remember, that's our cardboard. The x value is our flap. Sorry, I'm drawing too much. So if this length was 16, this x value and this x value, because there are two of them, has to be smaller than 8, or we wouldn't have a box, right? So that's your physical restriction on the flap size. That's the x value. So from the graph, if you look at, right there is the maximum. X equals 2.9. So that's your flat value. And y, which is your volume, is 420 inches cubed. Okay, so we're going to make the cuts about 3 inches, and we would get a volume of about 420 inches cubed. So the dimension of the box is going to be, I need my paper, there we go. Length is 20 minus 2 times 3, or 20 minus 6, which is 14. Our width is 16 minus 2 times 3, or 16 minus 6, which is 10, and our height is 3. Sweet. All right. Graph the function, identify the x-intercepts and the points where the local maximums and local minimums occur. So our x-intercepts are going to be x equals -2, 1, 3, right? If I set up a t-table, x, y, I'm going to graph 1 behind it, -2. Let's just go straight for a 0. 1, 2, and 3, and 4. I know. But these are the ones that are crossing the x-axis. And I sort of need 1 before and after each one. But I can use my calculator. It's not a big deal. So there we go. Got all the points I need. Try to do a basic sketch. 1, 2, 3, 1, 2, 3, 4, 5, 6. That gives us that first point, -2, 0, 0, 3 halves, 1, 0, 2, -1, 3, 0, and 4, 4 1/2. 1, 2, 3, 4, 5. All right, there we go. Get our basic graph. Looking good. I forgot to include where my local maximas and minimas are. I had to put in my graphing calculator to find that. So my maxima is going to be at -0.79 and 2.1. And really, if you're putting it into your calculator, you can totally do that t-table also without actually crunching any numbers. My minima is going to be 2.1, -1.0. And that makes sense. 2.1, -1.0, and 0.79, 2.1. It must go up and that back down, up here. Cool. All right, graph the function, identify the x-intercepts and where the local maximas and local minimas occur. X, this is going to be a 1 and a 4, and that's going to be just a touch. So 1 and 4. I'm going to go ahead and put it in my calculator though, because I need to for my maximas and minimas anyway. So 0, 1, let's do 2 and 4. If I plug in 0, -1 squared is 1 times -4 times 2, -8. Plug in a 1, that's my 0, 2. So 2 minus 1 squared, 2 minus 4 times 2 out front. 1 times -2, -4. And then 4 was a 0. I did forget I need a value after the 4 too, right? So let's put in a 5 and see what happens. 5 minus 1 is 4. 5 minus 4 is 1. So 4 squared is 16 times 2 is 32. So where the 5 is, it's going to be way up there, like even further. So if I try to sketch this, I know I'm starting down here. And that's a touch. Sorry, that 1 is a touch. So really I'm going to assume that my maxima is around right here and my minima is going to be around right there. So now I'm putting in my calculator and figuring it out. This is number 2. So my minimum is going to be at 3, -8, which makes sense, okay? And my maximum is going to be at 1, 0, which makes total sense because that's exactly where I saw it. Okay, here, going straight for the graphing calculator. Okay, my graphing calculator, oh, I don't want red. Got my y-intercept, my x-intercept. Totally reading this, and I see where it flows. So I am going up, down, and up. So I need to find my maxima and my minima, and I got my x-intercept. So x-intercept is going to be at 3. Actually, if I went to the calculator exactly, it was -3.1. My maximum is going to be -1.7, 4.1. That's awful. -1.7, 4.1. Sorry about that. That was really bad. And then my minima, 0.39, 1.8. Okay, all on the graphing calculator. And this last one. So I should have 4 zeros here, but I threw up my graphing calculator. And 1, 2, 3, 4, 5. This seems to be where I cross the y-axis. 0, sorry, 1, 2, 3, 4, about right here. I'm gonna actually do the zeros on my graphing calculator. 1, 2, 3, 4. I look to be about 1.5. So what we're doing here, all on my calculator, I'm coming down, okay, back up, down, and up. I know that's what a fourth root looks like because we've looked at all of those. So I'm going to have a minimum, a maximum, and only 2 zeros. 2 of my zeros must not be real. They're just imaginary. So here I've got my x-intercepts at -3.1 and 1.4, all on my calculator. My minimums are going to be -2.3, -9.6, and 0.68, 7.0. And then my maximum is going to be -0.65, -3.5. Awesome. What if, in example 3, how do the answers change if the piece of cardboard is 10 inches by 15 inches? Okay, we have 10 inches by 15 inches. I'm still cutting out the x, right? So my volume, I shouldn't have done that. My volume is going to be my length, which is 10 minus 2x, times my width, which is 15 minus 2x times my height, which is just plain x. So I actually just realized this. I'm sure some of you have already realized it. I don't have to do my polynomial. I don't have to do all the multiplication to put this in my calculator. I can put it in my calculator just like that and maximize it. So when I maximize it, I'm going to get, goodness, like that. But I only want to look at my x-axis between 0 and 5 is where I want to look at my x-axis. So I want to look at that value right there. So the maximum value, this maximum is 132 cubic inches, and my x value is about 2. So that right there is the maximum at that point. So my length is going to be 10 minus 4, which is 6. My width is going to be 15 minus 4, which is 11. And my height is going to be 2. Sweet. All right, I've left the answers here for the daily homework quiz if you want to practice another one. Notice here, this is just a touch at x equals -3. That 0 is right here. And then the maximum and minimum I find by graphing them. And last, it's another cardboard box. Cool, good work.